Hi, I'm Ethan Kwan, and today I'm going to be showing you what the golden ratio is. What is the golden ratio, you ask? Well, I'll show you now. So, if you construct something like this, and you have this kind of thing, and you say this is side A and B, you'll get something like this. And I want to find some ratio that is A over B is, equal to, so I want these two things to be equal, okay? So how can these two be equal? Well, first, we have to assign something to this, so I'm just going to call it x, okay? So now that's okay with you, if that's okay with you. Yeah. Tell me what you wanted to call it in the comments below, okay? You can just solve this by doing this. You probably know that this is equal to A over A plus, and you probably know these two are equal. So those two are equal. So all of this is a way of representing x. So, and you also know that A over A is just 1, right? So 1 plus B over A is equal to x. And you should also know that B over A is basically the opposite of A over B. So this should simplify to 1 over x. So you can say that x, you know what, let me use that same color. You should also know that B over A is the opposite of A over B. So B over A is the opposite of x over, So A over B is the opposite of B over A. So over here, B over A is the opposite of A over B over here. So you should simplify this to 1 over x. So this is kind of interesting because x is equal to 1 over x. So this is also one of the things that are true. X is equal to 1 over x, which is kind of So this is kind of interesting because 1x is equal to 1 plus 1 over x. So just based on what we got here, we got to this thing. So x is equal to 1 over x. Instead of writing 1 over x, so 1 plus 1 over x, you could just do this. So x is equal to, and you could just write it the normal way. So you know this is also true. So if x is equal to 1 plus 1 over, and I might write x there, but we know that x is equal to 1 plus 1 over x, so you can do that again. So x is equal to 1 plus 1 over 1 plus 1 plus 1 over, and instead of writing x there, you could just write, again, 1 plus 1 over, and instead of writing x there, you could just keep going and going and going and going without ever stopping. So that's another factor that's kind of interesting. So this is also true, but we can just get rid of all that. So if this is true, then you should be able to multiply both sides by x to get rid of x here. So let's do that. So if you multiply x by both sides, it's just going to end up as x squared is equal to 1 plus x. If you think about it, that makes sense. So now let's square root both sides. If you haven't seen the video on square rooting, click up here. Never mind. So that's that. So now you should be able to solve this kind of. So eventually you're going to get x is equal to 1 plus 1, no. So eventually you should get 1 plus the square root of 5, all of that over 2. All of that over 2. So this is the equation you should get. Now, this thing, let's get out the calculator to solve it. So this thing is 1, so this whole thing is 1 plus 5 square root. Well, whatever. So this should all equal to 1 plus the square root of 5. 1 plus square root of 5. All of that divided by 2, which should equal, I think I did something wrong there. So let's get out the calculator here to solve it. So let's calculate this. So it's 1 plus, so it's 1 plus the square root of 5 divided by 2. So it should get you 1.61833988875. So let's write that down. 1.6188033. Round to the nearest thousandth, so it's going to be 1.618. So this whole thing, so x is going to be equal to 1 plus 1, no, x is going to be equal to 1.618 something, I think. So it's 1.618. So it's 1.618. And x is now the golden ratio, or 1.61803, so on. So that's how to get the golden ratio from all of this crazy math. So that's how the golden ratio was invented, and that's how to prove the golden ratio, and that's how you use the golden ratio in a bunch of photos, which is kind of interesting because it appears in like nature and all that stuff. So here's an example. If I draw this thing, which is called a golden rectangle, let's say this is side A and this is side B, and let's construct a little square of B. So this is going to be A minus B. And this is going to be B. Now let's construct another square of A minus B. So this is going to be like that, A minus B. So this is A minus B. So, and then continue like that, like that, like that, like that, like that. And you might recognize a pattern here. So if I draw from here, so if I draw something like this, you probably recognize this. This is the Fibonacci thing. So the golden ratio represents all of these things. So that's what I know about the golden ratio. Bye. See you at howtodostufwithethan.com, and see you next time. Bye.